Alright guys, your essential question for today is how can we describe the ambiguous case for the law of signs? Your vocabulary word is ambiguous case. Alright, ambiguous basically means uncloudy or not known. So the ambiguous case for the law of signs is an issue that we run into whenever we have a certain type of triangle. Alright, now if you remember from your 10th grade year in geometry, you found that you could prove two triangles were congruent using some different congruency theorems. And these congruency theorems were side, angle, side, angle, side, angle, 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 side, 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 or even hypotenuse leg, which is good for right triangles only. But you did these congruency theorems to prove whether or not two triangles were congruent. So for example, with side, angle, side, if this side was equal to this side, and this angle was equal to this angle, and this side was equal to this side, then you could say that both of these triangles were congruent or equal to each other by those congruency theorems. Well, there was one congruency theorem that you couldn't use, and that one that you couldn't use, a lot of teachers say that it's the curse word. I'm just going to write it as SSA, but a lot of people write it as ASS. But that's where you had side, side, and the non-included angle. You couldn't use that because you can't prove that two triangles are congruent from side, side, angle. Alright, now fast forward, we're going to use that idea with trig today. It says, by definition, the word ambiguous means open to two or more interpretations. Such is the case for certain solutions when working with the law of signs. Alright, now, here's the key point. If you are given two angles and one side, such as angle, side, angle, or angle, angle, side, the law of signs will always nicely provide you with one solution for your missing side. So that it works out perfectly. Unfortunately, the law of signs has a problem dealing with the SSA. If you are given two sides and one angle, where you must find an angle, the law of signs could possibly give you one or more solutions, so one or two solutions, so one triangle or two triangles, or even no triangle at all. So you have to be very careful. So just know that this ambiguous case only applies to one specific stipulation. It's when you're given the information of side, side, angle. Okay, so that's what's crucial. That you can only this only applies when it's side, side, angle. Okay, well, I'm going to go ahead and jump right into it and go ahead and give you what the steps are to determine if you're going to have just one answer or if you're going to have two, I shouldn't say answers, one triangle or two triangles. Alright, so here are the rules. Step to success. Step one, just go ahead and use the law of signs as normal to find the angle of your triangle, of that situation. So just use the law of signs normally. If you get an answer for your angle that works, then obviously then you have at least one solution. If your calculator says undefined, or if, for example, you get an angle that's too large to be the second angle, then you have no triangle or no solution. Now, how do you determine if you have more than one triangle? Well, look at step two. If after you use the law of signs, and you get that angle, if you take that angle and subtract it from 180, if your new angle plus the given angle, because you're going to be given an angle to begin with, is less than 180, then there are two triangles. In other words, there are two solutions to the problem. Okay? So that means that there's two solutions. If the new angle plus the given angle is more than or equal to 180, then there's only one triangle, so only one solution. So that's how you tell whether or not you have one triangle or two triangles, or in fact if you have no triangles. So let's go ahead and take a look at an example. I'm going to go back and look at example 1. And here's my situation. It says in triangle ABC, A is 20, C is 16, and angle A is 30. I'm just going to draw a generic triangle and label it A, B, C. And it says that side A is 20, side C is 16, and angle A is 30 degrees. And then I'm going to look and check. I notice this is side, side, angle. And so this is side, side, angle. I have to watch out, and I have to watch out for the ambiguous case to know whether or not this triangle might not even work, or it might just be one triangle, or there might be two triangles that could represent this situation. So what I'm going to do first is I'm just going to go ahead and use the law of sines. I'm going to match up 20 with 30 degrees, and I'm going to match up 16 with angle C. So if I use the law of sines, I'm going to have C over sine of 16 equals 20 over sine of 30. I'm going to cross multiply, so I get C sine of 30 equals 20 sine of 16. To solve this for angle C, let me regroup that. That should be 16 over sine of C. All right, so let me try that again. Cross multiply, get 16 sine of 30 degrees equals 20 sine of C. I'm going to divide by 20, and since I'm trying to find angle C, I know I'm going to have to do sine inverse. So sine inverse of 16 sine of 30 degrees over 20. And if I do that in the calculator, I get approximately 24 degrees. So this is possibly one of my answers. Well, immediately I'm going to go ahead and check, and so I'm going to do it over here in blue. I'm going to check to see if there is a second possible triangle. So the way I do that is I'm going to take the angle I just got, and I'm going to subtract it from 180, and then that's going to give me 156 degrees, and then I'm going to add the original angle I was given, which is 30 degrees, but that gives me 186 degrees. So that's more than 180, so then there is no second triangle. There's only just this one triangle. Okay, so with that being said, now I can find angle B. I can add these two angles up and then subtract that from 180, so I'll get 126 degrees for this angle. And now I can find side B by doing B over sine of 126 degrees equals 20 over sine of 30. I'm going to cross multiply, so I get B sine of 30 equals 20 sine of 126. I'm going to divide by sine of 30, and so that'll give me, it's 20 sine of 126 divided by sine of 30, and that'll give me approximately 32.4. And that would be the length of that side. All right, let's take a look at another example. For example 2, it says in triangle ABC, side A is 7, so I'm just going to label this A, B, C. Side A is 7, side C is 16, and angle A is 30 degrees. I'm just going to double check. This is side angle. So definitely I need to check and make sure, because this could be a no triangle. It could be one triangle, or it could even be two triangles to fit this situation, the given information. So I need to check it. Well, I'm still going to use my law of sines, so I'm going to pair up the 7 with the 30 degrees, and I'm going to pair up the 16 with angle C. So that's going to give me 7 over sine of 30 degrees equals 16 over sine of C. Cross multiply, that gives me 16 sine of 30 equals 7 sine of C. Divide by 7, and since I'm trying to find the angle, I'm going to do the inverse. So I'm going to have sine inverse of 16 sine of 30 degrees over 7. But when I type that into my calculator automatically shoots back undefined, or I'm not able to get an answer. So in this case, there is no triangle or solution that would fit these three characteristics. In other words, I couldn't have a triangle that has an angle of 30 degrees for A, a side of 7 for A, and a side of 16 for C. There is no such triangle that could form. Now that's one good thing that the law of sines can show you, is that if there's no triangle. All right, let's look at one more example. So for this one, it says side A is 10, side B is 16, and angle A is 30 degrees. So side A is 10 and side B is 16. Again, I'm going to double check, but this is side angle. So definitely have to watch out and see if there might be one triangle or two triangles or even no triangles. All right, so still going to partner up the 10 with the 30, but this time I'm going to partner up the 16 with angle B. Alright, so let me do the law of sines. I'm going to have 16 over sine of b equals 10 over sine of 30. Going to cross multiply, so I get 10 sine of b equals 16 sine of 30. I'm going to divide by 10, and since I'm trying to find angle B, I'm going to do sine inverse of 16 sine of 30 over 10, and my calculator is going to give me roughly 53 degrees. Alright, immediately what I'm going to do now is I'm going to check to see if there is a possible second triangle. So I'm going to take 180 degrees, I'm going to subtract the 53 degrees I found, and that's going to leave me 127 degrees. I'm going to add the angle that was given, which is 30, and if this is less than 180 degrees, that means that there's a second triangle. It is less than 180 degrees, so that means that my second angle, my second triangle, has an angle B that is 127 degrees. So in other words, I could go ahead and draw out my second triangle, and I know that B is my obtuse angle, so that will be 127 degrees. Some other stuff I already know is that angle A is still 30 degrees, and that side A is 10, and side B is 16. So now I've got two separate triangles that I need to solve for. I'm actually going to go ahead and solve the first one. We said that angle B was 53 degrees right there. So the quickest thing for me to do for this triangle is to find angle C. The way I could do that is add the 53 and the 30 and subtract that from 180. That's going to give me 97 degrees. And so now I can find side C. I'm going to have C over sine of 97 degrees equals 10 over sine of 30. Cross multiply, I get 10 sine of 97 equals C sine of 30. So I'm going to divide by sine of 30 degrees to solve for C. And so if I do that, that would be 10 sine of 97 divided by sine of 30. That would give me 19.9. So that would be the length of this one. So this triangle is fully solved. And then if I did this one, the missing angle, if I added these two up and subtract it from 180, that would give me 23 degrees. And then now I can find side C. It would be C over sine of 23 degrees equals 10 over sine of 30 degrees. Cross multiply. So I get C sine of 30 equals 10 sine of 23. Divide by sine of 30, and so I'll get C is equal to 10 sine of 23 divided by sine of 30. That would give me 7.8. So that would be 7.8 for sine C. But the key thing I do want you to notice is that these two triangles, both of them say that A is 10, B is 16, and angle A is 30, but you notice how these are not congruent triangles. And that's what the ambiguous case for the law of sines helps you find. Just in case you might have two triangles, which is this example, or you might just have one triangle, which is just like this example, or it could be possibly a situation where there is no triangle that can be drawn with the given information. So remember though, the ambiguous case for the law of sines only applies to one specific type of condition. Only if you're working with a triangle where the side, and a not included angle are given in the problem. Alright, that's all for today's lesson.